Algebra 1 Common Core, Unit 5, Section 8. If you're following this whole chapter, there is no video for Unit 5, Section 7. So it went from 5.6 to 5.8. So what we're doing here in 5.8 is modeling linear functions. So we're very familiar at this point with y equals mx plus b, where our slope m is our rate of change on the graph. We've called it a couple of different things throughout the series. We've called it, the rise over run, the change in x, the change in y over the change in x. But remember, it is always y over x, right? Y on top, rise over run. But rate of change is a good way of thinking about it, and that's very helpful when you get to these modeling questions because it's how the graph is changing. A steeper slope, versus a flatter slope like this first line that I drew here. I'll put it in a different color so you could see the difference here. I'm going all the wrong places. So this, there we go. This red line has a steeper slope than, say, like this blue line. You don't have to draw these lines. It's okay if you did. But, so we would say that this red line is a steeper slope. And so what that means is it has a greater rate of change. Things, it's going up faster than the blue line is going up, relative to horizontal. And that's really what we're talking about. And we're gonna continue talking about that concept of rate of change in the next video, 5.9, when we specifically talk about the average rate of change. So we're gonna hit that a lot in video 5.9. Your y-intercept b, when you think of it as modeling questions, it's helpful to think of it as the initial value. A lot of these things refer to your x-axis as an interval of time or some other type of input, but a lot of times it's good to think of it as kind of where the function starts, and that when we're graphing lines, that is where we start our graph, right? We start on the y-axis and then use our slope to plot points and connect the dots. So let's look at an example. The cost of airing a commercial on television is modeled by the function C of n equals 110n plus 900. Now C of n is like f of x, but they're saying that the cost of airing the commercial is based on this formula. So how much does it cost, if I wanted to make an ad and put it on a TV channel and air that commercial, how much would it cost? Well, this formula is going to give us the cost, where n is the number of times the commercial is aired. So for example, if we did C of, 3, where I want my commercial aired 3 times, that'd be 110 times 3 plus 900. 110 times 3, that would be 330 plus 900. 330 plus 900, that would be 1230. So it would cost, $1,230 to air my commercial 3 times. So this formula gives me the cost of how much it is to air a commercial based on how many times I want it aired, n. What they want to know is, based on this model, what do the numbers 110 and 900 represent? Well, doing this little demo here I think is very helpful. Then notice whatever number I plugged in, I plugged in a 3 here. If I plugged in a 5, I plug in a 7. Whatever my input is, I have to multiply 110 by that. So 110 is essentially acting as our slope here. Like this is kind of your mx plus b. And so 110 is, the cost per airing of the commercial, the cost, the amount of money it costs each time to air the commercial. So let me say that 110 represents the cost, to air each time. And in the context of this problem, this is the slope. Because each time, like if I wanted to, instead of 3 times, I wanted to air it 4 times, well, I would just take this and add 110 to it. If I wanted then to go 5 times, I'd add another 110. So it's, plus 110 each time, plus 110, plus 110. Every time I air the commercial, it's another $110. That's the rate in which my cost is increasing. So it represents the cost to air each time, or the rate of cost increase is a good way of thinking about it too. So what does that 900 represent then? Well, the 900, notice that no matter what number I plug in here, it's going to be times that, but it's going to be plus 900. So even if I err it one time, it's 900. Even if what if I don't err it at all? What if I plug in a 0 here? Well, then why does it still cost me 900? So if I make a commercial and don't air it at all, I still have to spend $900. So that must represent the cost it is to make the commercial, or to set up the account with the television network before you even produce the commercial. So 900 is the starting cost to make the commercial. It's the starting cost to make the commercial. It is the initial cost. It is the y-intercept of the function. It's where everything starts. That no matter how many times I air this commercial, it's going to cost me at least $900. It's going to cost me $900 to kind of get started. That's why we call it initial, because it's like the beginning. And then it's going to cost me $110 each time the commercial is aired. So that's what your slope and y-intercept kind of represent here. Your slope is your rate of change, the rate in which the cost of this commercial is, costing me to air it. And my y-intercept b is the initial value. It's costing me $900 just to get started, and then it goes up 110 from there. So this is basically it. This is what modeling linear functions is. It's kind of taking a look at a linear equation, y equals mx plus b, but in the context of like a real world problem, and understanding that slope is rate of change and what that means in the context of the problem, and the same for y-intercept. So here, instead of giving an equation, we want to kind of create one here. So Jackson is starting an exercise program. The first day, he will spend 30 minutes on a treadmill. He will increase his time on the treadmill by 2 minutes each day. We want to write an equation or create a function, d of t, for the time in minutes on the treadmill he spends on, day D. So on the first day, if we were to make like make a table, on the first day, he's spending 30 minutes. On day 2, since he's going to increase his time by 2 minutes each day, he would spend 32 minutes. On day 3, he's spending, not 24, 34. That was 32. On day 3, it's going to be 34. On day 4, it's going to be 36, and so on. So what is my slope and what is my y-intercept? Well, my slope here is, the rate of change. How is this increasing? It's increasing by 2 minutes per day. Notice that this is, as this increases 1, 2, 3, 4, this is going up plus 2, plus 2, plus 2. Just like for this cost here, it was plus 110, plus 110 each time that I aired the commercial, where this is each day he's adding 2, adding 2, adding 2. So that's my slope. The y-intercept here, this is a little tricky, this piece, because remember, your y-intercept is when your x is 0. And so it's kind of like, the first day he spends 30 minutes on the treadmill. I think it depends on how you define that. Is the first day 0, or is the first day 1? And that's what I don't love about these questions, is it could be a little tricky. I think what they mean in this question is they want you to think of this as on the first day, like when he begins this, he's running 30 minutes. One day after that, he's running 32 minutes. One day after that, one day after that. So this is on each day after the first day. So in the first day, his initial value, remember you want to think of your y-intercept as your initial value, he's beginning this exercise routine by doing 30 minutes, and then it's going up 2 per day from there. So this is like a y equals 2x plus 30. He's starting at 30 and then increasing 2 per day. We want to write it in the function notation they tell us to. So t of d equals 2, instead of x, we're using t of d. It's not t of x. So 2d plus 30. And so that would be our function here. And then the follow-up question here is simply find t of 6. You know, how much he spends on the 6th day. Well, the 6 on day 6. So on day 6, that would be t of 6. Well, that's 2 times 6. Remember, d is just representing our input here. So whatever we plug in, so on. On day 6, it'd be 2 times 6 plus 30, which is going to be 12 plus 30 equals 42. So on day 6, it'd be 42. Again, what I don't like about this is, you know, on day 6, are we talking about 6 days after he starts, or, you know, is day 1, you know, that whole kind of argument there. But t of 6 based on our function here is 42. And I think t of 6, you'd have to think of that as 5 days after the first day, kind of thing. So that's going to be a little confusing. I don't think there's enough clarity in this problem on how they want you to do that. But understanding that the initial value is 30 and your rate of change is 2 is really the underlying big pieces here. And be able to create the equation or read the equation in the context of a problem is really what we're learning here. So that's 5-8 modeling linear functions. See ya.